Welcome to day 14 of the TryHackMe Advent of Cyber 2023 edition thingy, exclamation point ultra extreme. Today we're going to do some Jupyter notebooking, and I actually had to do some hacking before this video to get the Jupyter notebook in an accessible manner. You might remember from video, let's see which one that was actually. There wasn't a task with an inaccessible let's see, was that 7? Log analysis. No, I think it was 2. Day 2 that had a inaccessible Jupyter notebook in it. And I had a bit of a rant about that, and I decided today, like, you know what? It's gonna happen again. Let's see if we can make anything happen to fix that issue. And obviously I know a little bit more now. I've done a couple of these where I can just enable SSH. I actually didn't ever think of trying to do that before. So what I had to do before I even started this video was I started the video by basically enabling SSH on the machine, which took a bit of doing because this is obviously not accessible at all, the machine in its current form. So it's a lot of OCR and pressing keys and hoping that they do what you're expecting them to do. In this case, I had to go into the applications menu, scroll down to the Sstem Tools menu, find the terminal in there. From there, it was pretty smooth sailing. Had to go into .ssh, remove authorized keys, put my own one in there, including my idrsa.pub key, which I did. Then the second part came. I had to figure out how to get a Jupyter instance running on that machine that I could access from remote. And it's actually already almost there. There's just a password that it needs to log in, and we don't have that password, but there is a .jupyter notebook, .jupyter folder in the home folder that I found that had a server config.json file in it that had a password hash in it. And I deleted that file. And then in the home folder, I found a start.sh shell script, which just runs the Jupyter-lab commands with a few command line switches, which told me there wasn't really anything else that needed to be done to make sure that the notebooks folder was imported. That seems to just happen by itself. I'm not entirely sure how that works. I'm assuming there is a config somewhere. I did do a show config. I just don't remember now if there was actually a node for where the notebooks are supposed to be stored. But there is a notebook folder in the homes folder. That I did not need to explicitly point towards. I just sort of found it when I did start it again, because I used that script again without the password file present, and that allowed me to log in straight, no problem, which is what we're going to be doing again. So basically all I'm doing is I'm running the start.sh script again. It's going to say that there's already a port on 8888, which is fine. Makes perfect sense. I'm just looking at my VS Code. There should be a speech panel again, so you can see what NVDA is saying. We don't do that much command line things today. Oh, it's a bit fast. Let me slow that down a bit.
Or copy and paste 40. File //home/ubuntu/.local/share/jupyter/ to access the server. Open this file in the browser. File or http://tryhacme:8889/lab token.
Yeah, 8889. Okay, so 89 is where the thing is. I'm going to just open a tab.
Google Chrome. S3 connect. Check your network connection.
With that, refresh.
Jupyter lab busy. Blank unselected.
And there is there's our notebooks, no problem. So we're going to be needing these in a little bit. Yeah. So the test emails.csv file and the spam detector.ipynb file and the emails dataset.csv file, which I'm going to assume we're going to need. So I'll open up the spam detector.ipynb. I think you just double click them. How does that work? Yeah, that certainly did something.
Speed. Move the cell down. Control. Create notebook actions. Navigation lamp. Enable debugger toggle button.
Let's see. I'm not super familiar with the Jupyter notebook, so give me a minute here.
Insert a cell below. Delete the set button. Edit multi-line import numpty as NP. Edit multi-line ** blank blank. Edit blank number. Edit number spam detector playground.
Here we are. Okay. We have the notebook open in a way that I really don't think the TryHackMe people foresaw me doing. Like, this is really the only way for me to read it properly. So, if you have a problem with it, well then, I tried the legitimate way and it didn't work, and then I had to hack your challenge to actually be able to read everything. So I actually had to do more hacking than most people for this challenge. But okay, now we are actually going to be doing the task, which is task 21, day 15. Machine learning jingle bell spam. Machine learning saves the day. These titles get more creative every day. All right. So, machine's already started. This story. Task banner for day 15. We don't get to know what's on there. Over the past few weeks, Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap of clicking on links and providing credentials. Spam emails are somehow ending up in the mailing box. It looks like the spam detector in place. What? The spam detector in place since before the merger has been disabled or damaged deliberately. Oh no, sabotage. Suspicion is on McGreedy, who is not so happy with the merger. That darned dastardly McGreedy. Alright, image showing McSkitty. I like that. Someone tried alt text. I appreciate that. Problem statement. McSkitty has been tasked with building a spam email detector using machine learning, ML. She has been provided with a sample dataset collected from different sources to train the machine learning model. Okay. Learning objectives. In this task, we will explore different steps in a generic machine learning pipeline, machine learning classification and training models, how to split the dataset into training and testing data, how to prepare the machine learning model, how to evaluate the model's effectiveness. Lab connection. Before moving forward, review the questions in the connection card below. Okay, that basically just says start the target machine. A split screen video is available for the target. Yeah, and we created ourselves a direct link because we didn't have one. Deploy the machine. This may actually mean that I might go do the log analysis room at some point again, see if I can pull the same stunt on that server. I haven't tried that yet, but it might actually be doable. Sorry, CMnatic, if that was not your intention, but I'm gonna try. Deploy the machine attached to this task by pressing the green Start Machine button at the top right of this task. After waiting 3 to 5 minutes, Jupyter will open on the right-hand side. If you cannot see the machine, press the blue Show Split View button at the top of the room. It actually takes a while for this one. Like, I had to take actually 5 minutes or something before it came up. Overview of the Jupyter Notebook. Jupyter Notebook provides an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning, and scientific research. In this room, we will perform the practical on a Jupyter Notebook. Yes, I have wrestled access to it already. We have a graphic that says shows Jupyter Notebook layout. That is an alt text. Should be a bit more descriptive, but yes, that is an alt text. Thank you for putting it there. It's important to recall that we will need to run the code from the cells using the Run button or by pressing the shortcut Shift plus Enter. Each step is explained on the Jupyter Notebook for better understanding. Yeah, we can actually read that now. So we had the same issue with the, I think it was the second day where like most of the actual stuff was in the notebook and we couldn't really see it. Now we can. So yeah, if I can get this trick to work on the other one, I might do a supplementary video on that one. Let's dive into the details. Okay, here we go. Unlabeled graphic. Oh no, wow. Okay, this is the graphic alt text for this one.
Unlabeled graphic clickable at 2 and 9F6 to 9036 9BF 31,751,236,230,677.
Wonderful. Okay. Exploring machine learning pipeline. A machine learning pipeline refers to the series of steps involved in building and deploying an ML model. These steps ensure that data flows efficiently from its raw form to predictions and insights. A typical pipeline would include collecting data from different sources in different forms, pre-processing it and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning models and predictions. A graphic that says show machine learning pipeline. See, what I call these non-alt texts, because yes, there is an alt text, but it tells me absolutely nothing about what's actually on the image. So some constructive criticism here. Tell me like what the pipeline contains. Tell me how you visualized it. Tell me what the actual image contains. The idea is that if you close your eyes and you hear that description, you need to know what's on the image. So that is what alt text is generally meant to convey, like an actual alternative, a full featured alternative for an image if you can't see it or it won't load for whatever reason. So good attempt, but be a little bit more detailed. Whoever wrote this, I appreciate it, but this is just what I'm giving you as a bit of feedback here. Step 0, importing the required libraries. Before starting with data collection, we will import the required libraries. Jupyter Notebook comes with all the libraries we need for machine learning. Here we are importing the two key libraries, NumPy and Pandas. These libraries are already explained in detail in a previous task. Yeah, I'm pretty sure the same person wrote these two tasks, so that's cool. Import NumPy as NP, import Pandas as PD. Yeah, fair enough. Let's start our spam email detection in the step 1. Oh, in the following steps. Okay. Do I need to run this? Like there's a cell here. Do I need to run anything yet? Let's help McSkitty in developing an effective spam. Okay, yeah, whatever. In this activity, oh, I don't think we're doing this yet. Okay. Step 1, data collection. Data collection is the process of gathering raw data from various sources to be used for machine learning. This data can originate from numerous sources such as databases, text files, APIs, web scraping, and many others. Here we are using the Pandas library to load the data collected from various sources in the CSV format. The dataset contains spam and ham, non-spam emails. I've never heard that term before. Who came up with that? Okay, code sample that says data equals pd.readcsv emails dataset.csv. I'm pretty sure that's somewhere in this notebook as well. We'll look at the notebook after we've read all this. Test/check the dataset. Let's review the dataset we've just imported. The category column contains the email classification, and the message column contains the email body, as shown below. Print data.head. Okay. Expected output. Okay, so classification. Yeah, 0, spam, congratulations, you have won the free ticket. 1, ham. Call me back when you get the message. Okay, 2, ham. Nah, I don't think he goes to USF. He lives 3, spam. Free message. Hey there, darling. It's been 3 weeks now. Okay, ham. Even my brother is not like to speak with me. Oh dear, the English. Tabular representation of data. That's. Oh, I think I missed a bit. Data frames provide a structured and tabular representation of data that's intuitive and easy to read. Using the command below, let's use the Pandas library to convert the data into a frame. It will make the data easy to analyze and manipulate. Okay, that's print df. Wait, what? Oh, df equals pd.dataframe, dataframe with capital D, capital F, and then the data. So we stick the data in there and then we print it. And that throws... I don't see a difference, but I guess it looks better. Okay, it actually looks more annoying for me in this representation, but that might just be the way it's done with how this has been put into the task. Okay, so that's 50, 55, 50. There's a lot of data in here. Okay, 5,570 rows times 2 columns. That's a lot of data. Step 2, data pre-processing. Data pre-processing refers to the techniques used to convert raw data into a clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and incomplete, pre-processing is an essential step to ensure that the data feeding into the ML models is relevant and of high quality. Here are some common techniques used in data pre-processing. Technique description. Use cases. Cleaning. Oh, okay. And use cases is the third column, my bad. Cleaning. Correct errors, fill missing values, smooth noise, and handle outliers. To ensure the quality and consistency of the data. Okay. Normalization. Scaling numeric data into uniform range, typically 0 to 1 or -1 to 1. When features have different scales and we want equal contribution from all features. Yep, fair enough. Standardization. rescaling data to have a mean, mu, like the Greek letter mu, of a standard deviation, sigma, of 1, unit variance. When we want to ensure that the variance is uniform across all features. Okay, then we have feature extraction, transforming arbitrary data such as text or images into numerical features to reduce the dimensionality of data and make patterns more apparent to learning algorithms. Okay. Then we have dimensionality reduction, reducing the number of variables under consideration by obtaining a set of principal variables to reduce the computational cost and improve the model's performance by reducing noise. And then we have discretization, transforming continuous variables into discrete ones. Okay, to handle continuous variables and make the model more interpretable. Okay, so that's, I'm sure that you know what you mean, but that is really like opaque for people who have no idea what you're talking about. I hope this gets more explained further down. Text preprocessing, tokenization, stemming, lemmatization, etc. to convert text to a format usable for ML algorithms. To process and structure text data before feeding it into text analysis models. Okay. Imputation. Replacing missing values with statistical values such as mean, median, mode, or a constant to handle missing data and maintain the dataset's integrity. Okay. Feature engineering, creating new features or modifying existing ones to improve model performance, to enhance the predictive power of the learning algorithms by creating features that capture more information. Utilizing count vectorizer. Machine learning models understand numbers, not text. This means the text needs to be transformed into a numerical format. Count vectorizer, a class provided by the scikit-learn library in Python, achieves this by converting text into a token, word, count matrix. It is used to prepare the data for the machine learning models to use and predict decisions on. Okay. Here we are using the count vectorizer function from the sklearn library. From sklearn.featureExtraction.text, import count vectorizer. That's where it came from. Okay. Vectorizer equals count vectorizer, and then you just give it vectorizer.fit transform, and then you just give it the data frame, a parameter of the data frame, which in this case is message. I guess it's the message body, and then we print X. Expected output would be 77, 401. I'm not sure what those numbers mean exactly, but I'm sure that this person understands it. Just scrolling through this stuff. It's all been, yeah, here's the rejected bit. Step 3. Train and test split dataset. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another. The graphic that shows that a dataset image split into test and training set. Okay, fair. Okay, good. We will use the functions from the sklearn library to split the dataset into training data and testing data, as shown below. So from sklearn.model_selection import train test split. Y equals dataFrame classification xtrain xtest ytrain ytest equals train _test split. Parameters x, y, test size equals 0.2, which I'm assuming is 20%. X, the first argument to the train. What? Okay, X, the first argument to the train test split is the feature matrix X, which you obtained from the count vectorizer. This matrix contains the token counts for each message in the dataset. Okay. Y, the second argument, is the labels for each instance in your dataset. which indicates whether a message is spam or ham. Test size equals 0.2. This argument specifies that 20% of the dataset should be kept as the test set, and the rest 80% should be used for training. It's a common practice to hold out a portion of the dataset for testing to evaluate the performance of the model on unseen data. This is where the actual splitting of data into training and test sets happens. The function then returns 4 values: xtrain, the subset of the features that to be used for training; xtest, the subset of the features to be used for testing; ytrain, the corresponding labels for the xtrain set; and ytest, the corresponding labels for the xtest set. Fair enough. Step 4, and I see a heading. I haven't seen any headings for the rest of it, and this is the wrong heading level, but still I appreciate the offer, the idea. I think it was just meant to make this text larger, but still, it's good to have it there. Step 4, model training. Now that we have the dataset ready, the next step would be to choose the text classification model and use it to train on the given dataset. Some commonly used text models are, here we go again, are explained below. He likes this list, doesn't he? Model explanation. Naive Bayes classifier, or Bayes classifier, a probabilistic classifier based on Bayes' theorem, with an assumption of independence between features. It's particularly suited for high-dimensional text data. Okay. Support vector machine, SVM, a robust classifier that finds the optimal hyperplane to separate different classes in the feature space, works well with nonlinear and high-dimensional data when used with kernel functions. Logistic regression, a statistical model that uses a logistic function to model a binary dependent variable, in this case spam or ham. Decision trees, a model that uses a tree-like graph of decisions and their possible consequences. It's simple to understand, but can overfit if not pruned properly. Random forest, an ensemble of decision trees typically trained with the bagging method to improve the predictive accuracy and control overfitting. I feel like I'm listening to like a university student's like thesis on this topic, but I'm already supposed to understand what everything means, and I'm just sort of passively absorbing this, and I kind of get what they're saying, but I just don't know for sure where we're actually at this point. Gradient boosting machines, GBM, an ensemble learning method, is building strong predictive models in a stage-wise fashion, known for outperforming random forests if tuned correctly. K-nearest neighbors, KNN, a non-parametric method that classifies each data point based on the majority vote of its neighbors, with the data point being assigned to the class most common among its nearest neighbors. K-nearest neighbors. I don't know what K means here. Okay, heading 1. Model training using naive Bayes. Naive Bayes is a statistical method that uses the probability of certain words appearing in spam, whether a new email is spam or not. How naive Bayes classification works. Let's say we have a bunch of emails, some labeled as spam and others as ham. Yes, we do have that. The naive Bayes algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears in spam or ham emails. For instance, words like free, win, offer, and lottery might appear more in spam emails. The naive Bayes algorithm calculates the probability of the email being spam based on the words it contains. Fair enough. When the model is trained with naive Bayes and gets a new email that says, for example, win a free toy now, then it thinks win often appears in spam, so it increases the chance of an email being spam, further increasing the free is also common in spam, further increasing the spam probability. Toy might be neutral, often appearing in both spam and ham. After considering all the words, it calculates the overall probability of the email being spam and ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam. Otherwise, it's classified as ham. Fair enough. Let's use naive Bayes to train the model as shown and explained below. Okay. From sklearn.naive_Bayes import multinomial nomial nb. Okay. CLF equals multinomial nb. CLF.fit left bracket xtrain right train. Xtrain, this is the, yeah, we know what it is. We saw that already. This is the training data you want the model to learn from. It's the token counts for each message in the training dataset obtained from the count vectorizer. Yep, we know. By train, these are the correct labels. Yeah, either spam or ham. Yep, we know. This is where the actual training of the model happens. The fit method is used to train or fit the model on your training data. When we call the fit method, the multinomial NB model goes through the data and learns patterns. In the context of naive Bayes, it calculates the probabilities and likelihoods of each feature, word / token, being associated with each class spam or ham. These calculations are based on Bayes' theorem and the assumption of feature independence given the class label. Once the model has been trained with the fit method, it can be used to make predictions on new, unseen data. Step 5. Model evaluation. After training, it's essential to evaluate the model's performance on the test set to gauge its predictive power. This will give you metrics such as an accuracy, precision, and recall. All right. From sklearn.metrics, import classification_report. y_pred equals clf.predict left bracket x test right bracket. Print classification.report y test comma y pred bracket. Okay, expected output and a whole bunch of text. Okay. My cat keeps coming in the room and I keep telling it to not. Kind of interesting little development here. Alright, yeah, blah blah blah. Okay. So weighted average is 0.98. That might be good to remember. The classification report function takes in the true labels, y-test, and the predicted labels, y-pred, and returns a text report showing the main classification metrics. Precision, this is the rate of correctly predicted positive observations to the total predicted positives. The question answers is positive. Of all the samples predicted as positive, how many were actually positive? Okay. Recall, sensitivity, the ratio of correctly predicting positive observations to all the actual positives. It answers the question of all the actual positive values. How many did we predict correctly? This is so pedantic. F1 score, the harmonic mean of the precision and recall metrics. It gives a better measure of the incorrectly classified cases than the accuracy metric, especially when there are an imbalance between classes. Okay. Support, this metric is the number of actual occurrences of the class in the specified dataset. Accuracy, the ratio of correctly predicted observations to the total observations. Macro average, this averages the unweighted mean per label, and the weighted average, this metric averages the support weighted mean per label. Whew. The report gives us insight into how well your model is performing for each class and overall in terms of these metrics. Step 6, testing the model. Once satisfied with the model's performance, we can use it to classify new messages and determine if they are spam or ham. Message equals vectorizer.transform left brace today's offer. Claim your 150 pounds worth of discount vouchers. Text yes to 85023. Now Savamob. Member offers mobile. Okay. TCS 087. Yeah, a whole bunch of numbers. Unsub reply X. Okay. Whatever. Prediction equals clf.predict message. Okay. Print the email is prediction 0. What's next? McSkitty is happy that a workable spam detection model has been developed. She has provided us with some test emails in the file test_emails.csv and want us to run the prepared model against these test emails to test our model results. Test data equals PD read CSV something 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 something. A print test data dot head. Expected output blah. X new equals vectorizer transform test data dot message. New prediction CL feed blah blah blah. Okay, a whole bunch of code. Probably don't even need to do really anything much right now. Expected output, more emails. Conclusion. This is it from the task. From the practical point of view, we have to consider the following points to ensure the effectiveness and reliability of the model. Continuously monitor the model's performance on a test dataset or in a real-world environment. Collect feedback from end users regarding false positives. Use this feedback to understand the model's weaknesses and areas for improvement. Deploy the model into production. Okay. And that's the end of the task all of a sudden. What is the key first step in the machine learning pipeline? Is the first question. I guess that would be data collection, right? Is that correct? That is correct. Hooray. Which data pre-processing feature is used to create new features to modify existing ones to improve model performance? I'm pretty sure that was feature engineering. That's correct. Hooray. During the data splitting step, 20% of the dataset was split for testing. What is the percentage weightage average of precision of spam detection? What? I think that was 0.98. That's what I remember seeing. Yeah, that's correct. Okay, 0.98 is in the text. You don't even have to run the thing for that. How many of the test emails are marked as spam? Now, this is where we have to go look at the notebook. So let's go do that real quick. In this activity, we will help McSkitty build a simple spam detection using machine learning. As we are in a testing phase, we will use a small data sample. Okay.
Speech mode talk. As we are in the testing phase, we will use a small data sample.
We'll have the computer read the notebook. Why not?
Edit multi-line number step 0. Importing the required libraries.
Right.
Before starting with data collection, we will import the required libraries. Jupyter, NumPy, and Pandas. These libraries are already explained in detail in the previous task. Blank. **NumPy. **NumPy. Numerical Python is a fundamental package for numerical computations in Python. Blank. **Pandas. **Pan. Blank. Number step 0. Importing the required libraries. Edit multi-line import NumPy as NP.
Yeah, here they
Import
are.
Pandas as
So I
P.
guess we have to...
Notebook content region. Edit multi-line number spam detector. Playground. Number spam. Edit blank. And
okay, yeah, well, we just did shift enter to run that cell. I hope that went well.
Blank. Blank. Number step 0.
Can't really tell.
Edit multi-line number step 1.
Okay, step 1, data collection.
Data collection online route blank. Here we are using here.
Yep.
Number step 1. Data collection. Edit multi-line data.
So
equals
data equals. I'm just checking if the code is missing anything. Nope, it looks like that's correct.
Data equals page.red CSV emails dataset. Data equals page.red CSV emails dataset.csv. Edit multi-line data equals page.red CSV.
So I guess shift enter here as well.
Notebook content region. Edit multi numbers blank in this activity as we are in the test blank start blank number step edit date blank here we are number step data equal let's number print data.head print data edit multi-line. Let's review the dataset we just imported. The category column contains the email class of blank number test/check dataset blank. Let's review the dataset we just imported. The category column contains the email number test/check dataset.
So here we should be able to print the first data and see actual output. Let's see if that happens.
Content region. Out of region note kernel status progress R100. Blank notebook content region clickable markdown cell content. Clickable. Blank. Clickable edit multi-line number spam detector playground. Clickable edit multi-line import num clickable edit multi-line data equals page.red CSV out of it clickable. Markdown cell content. Clickable. Blank. Clickable edit multi-line number test clickable edit multi-line print data.head. Out of edit blank clickable.
Fireworks are going off. How cool.
Message. Zero spam this message last clickable. Edit multi-line print data.head.
Okay, yeah, it does look like we did get some output from that, so it looks like we're doing this right.
Zero spam this message is brought to you by GM Electron 9. 1 spam complimentary 4-star Visa holiday or £10. 2 am we made it data at Taunton is 12 free spam you are chosen to receive 2 am we made it data at Taunton is 12:30 as planned.
I'm just looking at these messages real quick because there might be some flag or whatever hidden.
Free spam you are chosen to receive a £350 award. PLS circa. 4 am they don't put that stuff on the roads to keep. Markdown cell content. Clickable.
Okay, looks good
Data frame
so
provide a structure and tabular representation of read. Use will make the data easy to and clickable. Clickable edit multi-line DFE. Edit multi make the data easy to analyze and manipulate. Make the data easy to analyze and manipulate. Edit multi-line DF equals page.data frame. Data.
Okay, we'll run this as well.
Content
Push.
Clickable edit multi-line print. Data.head. Clickable edit multi-line data frames for clickable print. DF blank. Out of edit clickable. Classification message. Zero spam this message is brought to you by GM Electron 9.
Yeah, I really don't see any difference, honestly.
4446 am ITHK 530 lore, but no can get tickets and not. 4446 am ITHK 530 lore, but no can get tickets and not.
Oh, I thought that was just a flag, but no, unfortunately not.
4447 am purity of friendship between two is not about. 4448 spam 5p4 Alfie Moon's children and need song on her. 4449 am sorry sir, I will call you tomorrow. Central 4450 am no 4449 am sorry sir, I will call you tomorrow. Central 4 dot. 4450 am no got new job at Barn Airport on Sstem. Blank. 4451 markdown cell content. Clickable.
Okay, fair enough.
Heading level 1 step 2 data preprocessing.
Yeah, here's the state 2.
Refers to the techniques used to convert raw understand message and clean it into the other several data pre the data. Clickable button create a duplicate of this cell below. Clickable button move this clickable blank button heading level 3 utilizing count vectorizer. Machine learning models understand into a numeric achieve this for the machine learn. Here we are using counter vectorizer which is used to extract clickable edit multi-line from learn.feature extraction.text import count vectorizer. Yeah,
we've already done all these, so I'm just going to run the cells real quick here. There we go.
Notebook actions navigation out of region note kernel status progress up blank notebook content region clickable edit multi-line y equals df classification clickable edit multi-line from slurm.model selection import train test split clickable edit multi-line vectorizer equals count vec clickable edit multi-line from slurm.feature extraction.text import count blank out of edit blank clickable markdown cell content clickable button create a duplicate of it clickable button move this clickable button and clickable blank. We will now use the count vectorizer function to transform the message column clickable edit multi-line multi-line vectorizer equals count vectorizer.
Shift, press enter to run the cell. It keeps scrolling me all the way up to the top when I do that. It's kind of annoying, that's why I have to keep scrolling down. That's a notebook thing, it's not something TryHackMe can do anything about. No, not quite yet. Yep, we just ran this.
Code cell content. Clickable button create a duplicate of this clickable button move this cell up and clickable edit multi-line print X.
And now we are printing X with this. There we go, and that should give us a bunch of numbers, if I remember correctly. Zoom.
Clickable edit multi-line from slurm.feature extraction.text import count vectorizer. Blank clickable blank out of edit clickable 060 043
there it is.
03641.
Here's all the numbers. We'll just scroll past these real quick. Blah, blah, blah. 40
clickable blank clickable button insert a cell click blank button heading level 1 step 3 train/test split data set.
Train split data set. Yeah, we'll be doing that.
Clickable edit multi-line from slurm.model selection import train test split.
Yep.
Edit from slurm.model
not too fast.
Here the variable x contains the data set. We will use the
yeah,
multi-line from slurm.model selection import train test split.
We'll import this. Very cool.
Clickable edit multi-line number spam detector. Clickable edit
scroll back down where we were. That's getting really annoying.
Number step 3 train/test split. Clickable edit multi-line from slurm.model selection import. Clickable edit multi-line y equals
and this is what we actually run to train the data set. There it goes.
Clickable edit multi-line from slurm.model selection import train test split.
Alright.
Blank clickable edit x train blank out of it clickable. Markdown cell content clickable blank bullet x the first argument the trains count vectorizer. This message bullet tests
let's go. We saw this before.
Bullet clickable. Heading level 1 step 4 model training using naive phase.
Model training.
Clickable edit multi-line from slurm.naive phase import.
We're going to import this. There
Markdown
it
cell content
goes.
clickable edit multi-line from slurm.feature extraction.text. Clickable edit multi-line vectorizer equals count vectorize. Clickable edit multi-line clickable edit multi-line from slurm.model selection import train test split. Clickable edit multi-line from slurm.naive phase import multinomial NB.
Yep.
CLF equals multinomial CLF.fit x train blank out of edit blank clickable 10 checkbox check fill down pointing small triangle multinomial NB fill down pointing small triangle multinomial NB markdown cell content clickable button create a duplicate of the cell below clickable edit multi-line from slurm.metrics import classification report.
Okay, we're going to run this as well. That should give us, I don't know if it's already done, but we'll see.
clickable.
Okay.
Clickable edit multi-line, clickable edit
Whoosh.
click X train, X test, Y clickable edit multi-line from slurm.naive phase import multinomial MD. Clickable edit multi-line blank, Y print, blank, out of edit clickable. Precision blank, precision recall F1 store support. Blank M 0.990.990.998.
Yeah, okay, it does look like it worked. Very nice. Accuracy 0.98, and the weighted score, that's where we got that score from. Weighted average is 0.98, which is what we filled into the question. And now we get to the bit where I think we have to fill in like one thing, which is like one file name or something. Let me find it. Classification report, yeah, blah, blah, blah. Message equals, yeah, okay. I believe that one. Test data equals read CSV blah. I need to go find out what that is called. Let me go find what it's called. It's called email dataset. No, the other one. Detector. Test emails.csv. So we'll copy that. We'll scroll down. I'll spare you all the screen reader output for the moment. I'll just quickly do it with Braille. That means we don't have to hit a clickable all the time. Here we are. Okay, so I remove these underscores here. Paste this in. And do Shift Enter to run this code. Whoosh. Roll down. Yep. Okay.
Speed out of edit clickable. Code cell content. Clickable button. Create a duplicate. Clickable button. Move this clickable edit multi-line print. Data.head. Blank. Out of edit clickable. Clickable edit multi-line x new equals vectorizer dot out of it clickable edit multi-line.
Okay, we will run this to make sure that it actually is working. The test emails, I mean.
Clickable edit multi-line print x.
If there is going to be a flag, it's probably going to be in the head somewhere.
Clickable edit multi-line from slurm.model selection import train test split. Click no next edit. Clickable edit multi-line print data.head. Blank. Out of edit clickable. Classified 0 spam. This message is brought to you by GM Electron 9. 1 spam complimentary 4-star Visa holiday or 10 pounds. 2 am we made it. Data at Taunton. This 12 3 spam you are chosen to receive a 350 pound. 4 am they don't put that stuff on the roads. Code cell content. 4 am they don't put that stuff on the roads.
The first 5 rows very well.
Clickable button create a clickable.
Now what do we do?
Clickable blank. Clickable edit multi-line x new equals vectorizer dot blank.
We make a vectorizer thingies. There we go.
Clickable edit multi-line print data.head. Clickable edit multi-line x new equals vectorizer dot transform blank. Out of edit clickable. Code cell content. Clickable button create a duplicate of the cell.
And then we have the new predictions. We'll do the new predictions as well. There it goes. Whoosh.
Clickable edit multi-line test data equals page.read.csv. Test emails.csv. Clickable edit multi-line new predictions equals clf.predict. Blank. Out of edit clickable. Code cell content. Clickable button create a clickable button move clickable button insert a cell clickable blank. Clickable edit multi-line
clickable until the cows come down, I guess. All right, whatever this does. Results df equals show me. There it goes. Run it all. Run all the things.
Clickable edit multi-line from slurm. Click. No next edit field. Clickable edit multi-line x new equals vectorizer dot transform. Clickable edit multi-line new predictions e blank. Out of edit clickable blank. 16. Clickable edit multi-line results df equals page.data print. Results blank. Out of edit clickable. Messages 0 reply with the messages prediction. 0 reply with your name and address and you will spam. 1 kind of. Took it to garage. Center part of X. Am. 2 fighting with the world is easy. Am. 3 why must we sit around and wait for summer day. Am. 4 oh am. 5 alert get a chance to win a $1,000 voucher. Spam. 6 I can't talk to you now. I will call when I can. 4 am. 7 today's offer. Claimer 150 pounds worth of discount. Spam. 8 don't worry. Oh am. 9 day mate spoke to the Mac people. We on. Am. 10 I sent you the prices. And do you mean the G am? 11 good morning. Am. 12 it's good. Am. 13 you umlaut tag in linear algebra today. Am. 14 days what's the plan this at. Am. 15 day I will be late. Meeting at 945 plus. Am. 16 I fetch younger you fetch. Am. 17 okay lore I net to go to pay 4 while to return. Am. 18 I like this sweater FR 17 okay lore I net to go to pay 4 while to return.
I net to go to pay a while to return. Wow.
18 I like this sweater FR mango.
If that's a code, then I don't know what it is. Heck.
19 what makes you most happy. Am. 20 no idea. Am. 21 all done. Am. 22 to 0 you have any ideas? Do you know? 23 yes dot is really great dot 24 a very inconvenient for your system. 25 great so what attracts you to the process. Am. 26 in life when you face choices just toss a coin. Am. 27 maybe you're right you know me well. Feel. Am. 28 somebody set up a website where you can play H. Am.
Is this AI generated or is he just
29
someone was really creative?
Am. 30 hello how's you and how did Saturday go? Am. 31 and very importantly. Am. 32 okay Chinese food on its way when I get fat you. Am. 33 I'm used to it. I just hope my agents don't DR. Am. 34 mode men or have you left? Am. 35 you have to PLS make a note of all she.s expose. Am. Markdown cell content.
Okay.
Clickable button move clickable button
yeah, looks good.
Clickable blank button. Heading level 3 once you have run the model against the test emails move on to the task to complete the answers. Clickable. Heading level 1 conclusion. This is it from the task. From the practical point of view we have to consider no next edit field.
Okay, I don't see...
Feedback to understand the model's weakness.
I think we have like one or two more questions to do. Let's see. How many of the test emails are marked as spam? So we just read all those. I didn't count them honestly, but I'm going to brute force this. I'm just not. I'm running out of steam here. I'm gonna start from 9, 8, 7, 6, 5, 4, 3. There it is. Okay, it was 3 emails were spam, apparently. One of the emails that is detected as spam contains a secret code. What is the code? What? Okay, hang on. I didn't see a secret code. Just going to look for the word spam. Which one has a secret code? And the first one, reply with your name and address and you will spam. Okay. Then number 5 is a spam. Get a chance to win a $100 voucher. And number 7, today's offer, claim your vouchers. I don't see any hidden code in these. Oh, can you expand these, I wonder? Can I see the rest of them? Because there's like a ... Okay, no, I can't. So what I would have to do is actually go look at the CSV itself. That's kind of meh. So it's 0, 5, or 7. Okay, so what? I have to go look at the test emails. Well, it's probably an easier way of doing it. Maybe it's just not accessible and I just don't see it. But CSV. Let me just really quickly open that file up. Test emails.csv. Can I see it? Do I have to double click it with the mousey? There. Okay. Oh, look. Okay, what is this?
Speech out of edit out of region clickable link skip the left sidebar. Link skip the banner submenu file. Menu out of emails test emails.csv. Dot. Spam detector.ipen. Left click. Blank. 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 Ops 29.0. Spam detector. Jupyter lab. Spam.
Oh, it jumped me into another thing. Okay, that's annoying.
16 days ago. Test email. Main landmark. Tab control. File browser section region. Side panel content region. Test emails.csv.
There they are.
Lab
Okay.
document. Test emails.csv. Jupyter alternate sidebar complement content info landmark. Search tabs menu button.
So what? How does this work?
Main landmark. Test emails.csv. No next take blank. Notebook content clickable. Blank. Out of region alternate sidebar complement tab debugger. Content click of 1. Clickable 0. Clickable test emails.csv. Test email clickable 0. Switch all alternate sidebar tab property inspector. Main landmark clickable. Out of region no combo box delimiter. New launch tab selected test email tabs new click combo box collapsed. Blank. Notebook content region clickable. Clickable. Blank. Out of region alternate sidebar complementary landmark tab property inspector.
Okay, how do I get
notebook alternate sidebar
the data in that?
Test emails.csv close test emails.csv property page. Notebook actions navigation landmark combo. Tab control launcher close file browser section region side panel content region file browser navigation
Let's
landmark
see
filter
here.
refresh the file browser upload files toggle button new folder button new launcher control plus new refresh fill side main testing alternate sidebar content info landmark simple switch off simple interface control plus shift plus D. Search tabs menu button sub menu.
What
test
if I
emails.csv,
turn that
main
on? Does that
landmark
do
test
anything?
emails.csv close test emails.csv property page alternate sidebar complement content info landmark simple switch on simple interface control plus file sub menu 1 of 8 search tabs toolbar not search test alter file browser refresh the file upload files toggle new folder button new launcher control plus main sidebar complementary landmark main sidebar banner landmark name test emails.csv path test emails.csv last saved 11/29/23 4:41 p.m. last checkpoint none edit selected test emails.csv.
Okay.
Skip the left sidebar link toolbar address and search bar edit
I don't know how to get at the access to
from mail
this.
remote Mailline
That is hilarious. Huh.
banner landmark name test emails.csv. Click of links skip the left sidebar link skip banner clickable main sidebar complementer tab running terminals and kernels tab extend file browser section region.
Well, if I
file browser
cannot
navigation
see it
landmark,
in a proper,
clickable
like
button,
fully
new folder,
accessible way of doing it, I'm getting so many emails. It's
clickable toggle button,
annoying.
unpressed upload files.
All right.
Clickable button refresh the file. Clickable filter files by name side panel content region. Clickable slash notebook slash. Clickable name. Last modify emails data set 16. Spam 6 test 6 out of combo box collapsed. Blank. Notebook content region clickable. Graphic. No next. Track no next. Test emails.csv close clickable. Blank. Out of region alternate sidebar complementary landmark tab property inspector.
Can I possibly download the file to my machine so I can look at it in another tool?
Clickable 0 clickable test main navigation out of menu bar content info landmark clickable to main navigation landmark clickable menu bar menu item menu item sub menu item
Let's try that. Let's just see if I can.
menu item new launcher menu item control plus shift menu item open from path menu item open from URL menu item new view for CS menu item unavailable new console menu item new view for CSV file menu item close tab menu item close and shut down menu item control plus menu item close all tabs menu item control plus S menu item save CS menu item save CSV file menu item save CSV file as menu item save all menu item revert CSV file to checkpoint menu item reload CSV file from disk menu item rename CSV file menu item duplicate CSV menu item download
Download.
test emails.csv Jupyter lab document.
I'm going to really quickly just look at this in a different editor because I do not know how to read this in
Speech mode off.
Jupyter notebooks. That's unfortunate because I'd like to be able to do that. There's probably a way to have it not truncate the lines like it has been doing. I just don't know what that way is. And I really don't want to find out right now. So I'm just really quickly going to just look at this in a different thingy. There's not that much anyway. Let me see. Test emails. CSV, unfortunately, is just text, so I can look at it in whatever I like. Oh my! We're just going to do Notepad++ for now. I'm not going to put OBS on there. It's a little overkill for just this. Just trust me as I'm doing this to figure out what it is. We can probably just look for THM once it's open. That's probably what I'm going to try first, honestly, because I want to be done with this task at this point. Yep, there it goes. Reply an address and you will receive by post a week's complement free of accommodation of various global locations. Okay, kind of. Okay, let's just search for THM. THM. Okay, so there's no THM. Ah.
Messages. Reply with your name and address. Messages. ESSAGES.
Reply with your name and address, and you will receive. Okay.
Kind reply with your name and address, and you will receive by post a week's completely free accommodation at various global locations. Kind of. Took it to garage. Center part of exhaust needs replacing. Hard order then taking it to be fixed tomorrow morning. Fighting with the world is easy. Why must we sit around and wait for summer days to celebrate such a magical sight when the world's dressed in white? Ooh, oh, let there be snow. Oh. Alert, get a chance to win a $1,000 voucher on your next purchase. I share the information about the best festival company. The secret code is IHT Best Tea Festival.
There we are. Okay. The secret code is I hate Best Festival. Okay.
I line H S T E line B S T Y F T S T I V selected. L selected.
I'm going to copy it into the field and I'm going to read it out loud. Yeah, I'll read it out loud myself because it has a bunch of capital letters and things in it. So here is the final question. With this code, this should be the white code, and it is. So it is. Here, hold on to your butts. This is an annoying one. Capital I underscore capital H small a capital T small e underscore capital B small e s capital T underscore capital F E S T I all small capital V A L. And there you have it. That's a small or a big L? Small L. Okay. That was the hacked together version. What time is it? We almost spent an hour doing this. That was the hacked into day 14, where I had to first hack my way into the Python notebook before I can use it. But the machine learning on its own, I don't know. I think it was very ambitious to stick a machine learning challenge in here without like the prerequisites being met. And as a result, I think a lot of terms are sort of thrown at you and you sort of remember them long enough for the question and then you forget them again. But that makes sense. This is an extremely large and complicated field. So like I said, ambitious to even put it in here. I like this. I actually like meant to go look at a bunch of machine learning stuff to begin with, and now I have because it's in the task. So this might be my start. I might like look into more of this next year. Anyway, this was task 14, day 14, task 20, I think. Yeah, 2 weeks of TryHackMe so far. What do I think? Accessibility wise, some tasks are perfectly accessible. A lot of them, unfortunately, aren't. And really what I've been doing to make things accessible is like, I don't want to brag, but a lot of people would not think of doing what I've been doing to make the screen reader accessible. Like I've been jumping through hoops that I really shouldn't need to jump through. So I hope that gets improved next year. I've left a bunch of feedback with a bunch of people. So I really hope that we'll see some improvements here. But for the moment, at least I'm thriving-ish with the help of AI now and again and the help of looking at videos. But that's only been necessary a couple of times. So honestly, so far, so good. Let's hope it stays that way. We're halfway. Oh, actually, we're past the halfway point. We're 2 weeks in. 10 more to go. And yeah, I'll give a retrospective at the very end as well. Probably in the same video as the task 24, the day 24 challenge. But yeah, for the moment, it's wadeable. That's really all I can say. Wade is in W-A-D-E. It's doable. It just takes a lot of doing sometimes. Like what I had to do was pretty ridiculous to even get access to the... Literally, there was no link to even access this notebook. I just sort of figured out that it runs on port 8888, so I just tried, and I got a password prompt. Literally, all they had to do is not put that behind a password and link it, and everyone would have been happy, and it would have been very accessible. Now, it wasn't, and it required me to do extracurricular activities to get into it even, so that was a shame. I hope we can learn from that, and yeah. That was this day's task. I hope this was educational, and I'll see you in the next one. Goodbye.